My name's Jay Johnson. I'm from Minneapolis, Minnesota. I'm a third-year mechanical engineering grad student here at UT, and I'm studying the acoustics of coffee bean roasting. My project involves listening to the sounds that coffee beans make while they roast. Many people don't know that the coffee beans that they drink and the coffee beans that they grind and get at the store start by being little tiny green dense coffee beans like the ones we have here. The process of roasting them and making them turn into the wonderful magic aroma that we know as coffee involves heating the beans up to such a temperature that they start to combust and start to burn. And at this roasting point, they start to crack. And they make a really interesting cracking sound that sounds a lot like popcorn or Rice Krispie treats. When you roast them, in order to get all of the right flavors, you have to know how long to roast them for. And what we're researching is how the acoustics and how the cracking sounds play right in to how the flavors are made. Small batch and artisanal coffee roasters use the sounds of coffee bean cracking to understand how far they are in the roasting process and to get the right flavors and the right characteristics of the coffee that they're making. This method has been used ever since coffee has begun being roasted more than 1,000 years ago. Nowadays, on a much more industrial scale and large-scale coffee makers, they don't have the microphone capabilities to accurately tell exactly where they are in the cracking process, and that's where we come in. We're trying to develop a method and an algorithm to count the coffee bean cracks and to understand exactly where we are. When I say where we are, what I mean is that after the first crack, you get to have a light roast, and as you continue cracking and that crack dies down, the second crack starts to come into play. And that tells you if you're in a dark roast or not. These cracks are very different from each other acoustically. They have very different frequencies, they have different amplitudes, and they have different rates at which they crack. And that's what we're trying to understand better so that we can use this information to understand a little bit better about how coffee beans are roasted. One way that our research might be used in the future is by implementing in a machine like this. This is a home coffee roaster. It's a simple device, looks kind of like a microwave. It heats up like an oven and roasts the beans. It takes about 20 minutes per pound. Something like this doesn't use the acoustics. You have to listen on your own. But we want to implement a method like a microphone and a little algorithm to count the cracks for you so that you can tell exactly where you are in your roast. Someday we hope to implement this on a much larger scale for an industrial size roaster such as Nestle or Starbucks, or ones you love. These sorts of coffee machines are a little bit too loud. They take up the size of almost an entire room, and it's difficult to hear the coffee beans cracking, but we're going to try and make a way to do it. For more information about the acoustics research going on at the University of Texas at Austin, visit the Texas Acoustics website. Thanks for watching.